Hey guys, I'm Pat Kelly. Okay, so here's what we have in front of us. Is if you notice, it's a differential equation. And in fact, it has an initial condition. And the directions tell us to use a Taylor series to approximate the first n terms, we're going to go for 5, of the solution to this differential equation. All right. Then if you remember, a Taylor series is actually a polynomial. So the directions further say to use that polynomial to approximate the y value for this given x. Our x will be the 1/2. So the purple for me is all the given information. Now let's get started. You can also notice that I started with the blue comment here. Comment, because I'm going to say what you need to do to start is to recall that this is kind of your formula for a Taylor series. Okay, so I don't know. I say recall, maybe I should put that in quotes because it depends how well you remember that. But even if you had to look it up, do whatever it takes to have that in front of you on your paper or in your head, because with this formula, if you will, for a Taylor series, it really guides you through the rest of the work that you need. Okay? If they want us to find 5 terms, you can see that I'm ready for 1, 2, 3, 4, 5 terms. And you can see in those terms that I'm going to need all the way up to a fourth derivative, right? So let's start our grunt work there is by getting some derivatives. I will need a y of 0 that's not a derivative, but I have that. That's that initial condition. Then I'm going to need a y prime. For that, I'm going to look to the differential equation. And for me, actually, this is convenient to take the y prime here and solve for it. In an equation, I'll end up with y prime equals, and I'm just throwing that second term to the other side. I think in order to do that, I'm going to end up switching what's inside the parentheses, switch the order of the subtraction, because of course when I throw it to the other side of the equal sign, it would be a negative of what it is. So that looks good to me. And I'm going to keep going. I have to find 3 more derivatives, but I'll also need y prime evaluated at 0, okay? So I'll do this for each of them just to get myself ready for that. Now that I have y prime, I need y prime of 0, and that's just plugging a 0 in for x, right? So 0 there, 1 minus 0 is 1, so I just get y. And I am plugging in a specific value of x, so y of 0. So in fact, that's just going to be 2 as well. So y of 0 is 2, y prime of 0 is going to be 2. All right, let's keep going. Differentiating, we do need the second derivative. So I'll differentiate the first derivative. Just be careful. It is a product rule because the parentheses depend on x and y is a function of x. So this is a product rule. And I'll do the derivative of the first, which looks like a minus 2. Second left alone, plus the first left alone, times the derivative of the second. And when I go to do the derivative of y, I'm just going to write it as y prime. Okay? Let me keep going since I'm in differentiation mode. And when I'm done with my 4 derivatives that I need, I'll back up here and do a green line for each of them as well and evaluate those derivatives at 0. Okay? All right, so my third derivative equals the derivative of minus 2y is minus 2y prime. Here's a product rule again, so I'm looking at a minus 2 times the second left alone plus the first left alone times the derivative of the second. So now when you're differentiating y prime, you're going to bump it up to y double prime. Okay. Now I think I only need one more derivative, right? Let's do that. Get that out of our way. So y, the fourth derivative of that. In fact, I think as I do this, I'm looking at a minus 2y prime minus another 2y prime. So that's minus 4y prime, which I'll differentiate to y double prime. And then I'm back to my product rule again, minus 2y double prime plus 1 minus 2x times y triple prime. Okay, and that's it for my differentiation. I'll switch gears, switch colors, and I'm doing the plugging in of the specific y value, the specific x value, and I'm looking at my formula, always guiding me here, is I do need a y double prime of 0, so here's y double prime of 0 is just putting a 0 in for x, so I get minus 2 times y of 0 plus putting a 0 in for x. Let's do a little bit of arithmetic on our heads. That's just going to be a 0, so there's a 1. There's a y prime of 0. And let's continue and evaluate that. Y of 0 we know is 2. I have a minus 2 in front, so that's going to be a minus 4 plus y prime of 0. We figured that out. We have it written down. That's the 2. So this is looking like a minus 2. Right? You very much you want to get numbers, real numbers at the end of these green calculations. Y triple prime of 0 equals minus 2 times y prime of 0 plus a minus 2. That's where I had the minus 4. I could have done that in this step here as well, but minus 2 times the y prime of 0 plus, this is blanking out to just a 1 then again. You do have your y double prime of 0. And then let's convert that to some arithmetic. Y prime, single prime, is a 2. Times a negative 2 is minus 4. Looks like I have 2 of those, so minus 8. And then y double prime of 0, that's what we did right above here, so that's a minus 2. And that looks like a minus 10. One more, I think. The fourth derivative of y, evaluated at 0. And let's try to do a little bit of plugging in our heads, I think, or on the fly, really, over here. Minus 4y double prime minus 2y double prime, that's going to be a minus 6 times, and the plugging in on the fly here, I just meant y double prime of 0, that's the minus 2. So let's just jump right to that and put it in. And then plus, the parentheses was that just 1 after I put a 0 in, and y triple prime, but evaluated at 0, that's this guy, so that's the minus 10. So our arithmetic here, what am I looking at? A 12, take away 10, looks like 2. All right, those are my y prime of 0 for each of the numerators. So I'm ready to go back to the formula, kind of plug it in. So down here, I'm really just following this formula for y, but putting in our particulars. Y equals, y of 0 was my 2, plus y prime of 0, which was also 2. And then there's an x from the formula, plus y double prime, and that y double prime at 0 was actually a negative 2, so I'm going to write that as subtraction. And that went up in the numerator. There's a 2 factorial in the denominator, and then x squared. Plus, then I look to my y triple prime. I'm thinking ahead though, yeah, that's also negative, so let's just write it as subtraction. 10 over 3 factorial x cubed plus, and my y to the fourth derivative of y, that was a positive 2, so 2 over 4 factorial x to the fourth, and then plus dot, dot, dot. In terms of our Taylor series, of course, going on forever, right? But they asked us in the directions to use the first 5 terms, so I've got them. And then we're supposed to approximate the y value at this x value of 1/2. Grab your calculator if you don't have it handy, but I'm going to take that 1/2 and plug it in here, wherever I see an x. So I'm looking for y of 1/2, and it's going to be an approximation. If I grab my calculator, and I'm plugging in 2 plus 2 times 1/2, which is 1, minus, and then 2 over 2 factorial, that's also just 1, times 1/2 squared, minus 10 over 6 times 1/2 raised to the 3 power, plus 2 divided by 24 times the 1/2 raised to the 4th power. Whew, hit enter, and I have an approximate value of 2.5469 with rounding. Okay. All right. So it's a good problem, good work. Make sure you try some on your own too, though. Okay.